Okay, so let us see how we handle this question here. It says a particle, a horizontal and vertical components of the initial velocity of a particle projected at point O. So this is our point O on a horizontal plane are P and Q. So this initial velocity that particle projected at this is going to be divided into two components. The Y component, the horizontal component, and then the vertical component. They are telling us that are P and Q. So also primarily divide our U there. So if we have my U there, I'm going to divide it into the vertical component. So if I divide it into the vertical component like this, so it's going to be my UX. Then I can divide it into another, the Y component. I can divide it into the Y component, UY. So that means that our UX is going to be P and our UY is going to be Q. From here, our horizontal and vertical components of initial velocity of the particle are P, meaning P is horizontal, then Q is vertical. Express this vertical distance of Y traveled in terms of horizontal distance, X and Y. So if they ask for the vertical distance, first of all, they first use our V equaling to U plus AT. Sorry? V equaling to plus our AT. This first equation of motion. So RV equaling to U plus AT. So the implies that now horizontal, our Vx is going to be Ux. Just so meaning acceleration in the horizontal direction is going to be 0. So in fact now my Vx is going to be Ux. What is my Ux? P. As simple as that. What about the horizontal distance? X is going to be Uxt. Because the other acceleration is 0. Okay. Minus a half V, which is 0. So 0 into t squared. So here my Sx is going to be Ux, which is Pt. But what is my Ux? My Ux is the horizontal distance, which they are telling us is x. So that is it. And when I come to Vy, is going to be Uy minus Dt. So my Vy will be my Uy, which is Q, then minus G. T. What about the Sy would be Uyt minus a half AT squared. So my Uy is going to be my Y equaling to my Uy, which is Qt, then minus a half G. T squared acceleration is negative because the gravity is acting downward. So if we have that and that, now they're telling us that express Y traveled in terms of X, P, and Q. So meaning now we have to express it, we make here T the subject and the substitute in there. So from here, it's that our T is going to be X over P. When you substitute into this equation, so we have now our Y equaling, that's the only way we have started. The real answer place it in terms of Q, P, and the X. So it means that we had to remove that T. So I'm going to be adding now Q, X over P, then minus a half G into X over P, the whole square. So from there, our Y is going to be XQ over P, then minus a half 2P squared, and square this one gets P squared times this, then D X squared, which you can easily get LCM. So from there, our LCM, our Y will be, our LCM is 2P squared. This one goes here, 2P, and that will get, shall get 2PQX, then minus DX squared. So that's what we have. So I've expressed now the vertical required to avoid it in terms of x, p, and q. Of course, the bracket is going to remain in there. Okay, find the greatest height attained by the particle. This was part A. Then part B, greatest height attained by the particle h. So using v squared equal to u squared plus 2as. If that's our greatest height, now we are going vertical. So mean that now our v squared y equal to u squared y, then minus 2bh. Because our height, I think that's that h there, is going to be that. So at maximum, the greatest height, so our at greatest height, vy 0. So we have 0 equal to u squared y minus 2bh. And from there, you start now, I can make my h the subject. So here I have 0 equal to my y squared is going to be q squared minus 2bh. We want to make h the subject, so our 2bh will be equal to h squared. Dividing through, our h is going to be h squared over 2b. As simple as that. So now that means that this is our height, the maximum height. Attained and the range. How do we get the range? The range is going to be the distance covered from here up to here. The range, now our range, for our range to happen, what happens at our range? It means that this particle has to come from here up there. For the range to happen, it means that now the distance covered, the result is going to be 0. Our x should be 0, which should be equal to x, because the particle is coming back there. Okay, so after having that, what happens? No, it's sy, sorry. It is sy. So this sy should be 0. Why are we saying that? The particle has not moved vertically. It means that for it to come from here up to here, our sy, this vertical displacement is going to be 0. So what is our vertical displacement there? We say it's our y. So if y is 0, then we can come and substitute now in there, in here, if it's 0 from here. Because it's 0, so now we want our range. So the range, we are going to come. So if our y is 0, so from here we can easily cross multiply there, and we can easily get our range whenever this is 0. Now, if y is 0, means that at this point here, the x we have covered some distance, but the y is the displacement vertically is going to be here at 0. So now putting it in our equation, which equation are you going to use? Putting it here, I'll be having now my 0 from sy. We have sy equaling to uyt minus g of g t squared. So if this is 0, now I have, if I factorize out t, I have u y minus d over 2t equaling 0. What is the time when it is 0? Or my yu equaling to dt over 2. What is my yu? It's here as q equaling to dt over 2. So the time there for that is going to be, now our time here is going to be 2q over g. So now if we have the time that requires us to cover from here to here, is this, implying that now we can get now the distance covered in terms of x from here up to here. So our x, remember our x is equaling to our xpt. But this x is going to be, by the time this particle is here, our x is going to be the range. So our r will be p times t, which is 2q that's how we get that range there. Okay, from there they're asking us now, and it has shown that y is equal to this. What is our y? Hence, the hence part, let us look here our hence part. Y, first of all, our y is here. So my y is equal to 2pq x minus dx squared over 2p squared. So what do you see? You see that in our part, we don't have anything like p, we don't have anything like q. So how are we going to remove them? Now, using this and this, from here I can make q the subject here. So making q the subject here, okay, if I make q the subject here now, from here I can say my q is going to be, from here, my q is going to be d r, it's going to be d r over dr over 2p. So if I make it a subject, then I square it because I'm saying here it's squared. So my q squared here is going to be d squared r squared over 4p squared. I call this equation, then you call it equation 1. So from here, from our h, remember our h is equaling to, our h is equaling 2q squared over 2d. From here, so my h squared is going to be 2hd. I call this equation 2. Now, instead those things are equal. This is equal to this. So, divide that 1 is equaling to 2. So, 2hd will be equaling to d squared r squared over 4p squared. So what does it imply? It implies that now this b can go there, then this I have there 8. So now my h is going to be r squared over 8p squared. Now from here, if we have 8p squared, I can come, I want to eliminate this squared here. If I want to eliminate p squared, it implies that now here 2p squared is going to be r squared over 2h. So can you substitute them here? So from there now my y is going to be 2p q. Where do you have 2pq? From here, that 2pq is r d. We have r dx, then minus. This one is what we are applying here first. Then minus dx, then over. Remember, we are going to divide with r squared divided by 2. Is it 2h? This is 4h. Yeah, that is 4h. When I divide this, I will come back to this over all h. It is going to make that reciprocal 4h. Wait, we had a d. One will remain there. So this d is in there. Okay, so instead of this d is going to be common, we divide through by that d. Then when h is going to take reciprocal, so that our x is there is common, so our y will be 4h. Then into what is common? Okay, r x minus x squared, all over now r squared. So now my y is going to be they factorized out x. So if I factorize out x also, I'll be adding r minus x, the whole over r squared, which is that proof they want us to show. So after showing that, they are telling us that given that the particle passes through a point, let us see how we handle part C. A particle is passing through a point 20, 80. This is going to be our x, this is going to be our y. Then they are giving us h to be 100 meters. So when you put there, it's that our y is going to be now 80 equaling to now 4h. So 4h we have 4, into 100 into x, which is 20, into r minus 20, the whole over r squared. You want us to get the velocity. How do you get the velocity? To get the velocity, now we're telling us that this point is passing through a point. Let me say this is a point 20, 80. It implies that it can pass it when it's coming up and also when it's going down. So that point is going to remain the same. So implying here, the vertical component is going to be from here. It's going to be 20. Then also, when it's here, this is going to be also 20 from there, the x component there. It can pass it through that point when it's going, and it can also pass through when it's coming down. So there is going to be the sketch there. Now from here, allow me to use this space. Okay, so from there now, if I cross multiply, so from here in my what I want is I want to get PQ because the velocity, because they're asking us find the velocity of projection. So they want us to get you and see that our is going to be the resultant. This here, which you can easily make as our resultant there. So they want us to get this. So now from there, when I cross multiply, you see by the way, I can divide it through by this 20 and this 4. We'll go with that. So we are having r squared. So my r squared will be equal to 100r when you open the brackets, then minus 2000, which when we solve our r squared minus 100r minus 2 plus 2000 equaling to 0. So when you put this on a bulldozer, you show the process of putting it on a bulldozer. So here I'm getting the first hour as 72.3606, and then I'm getting my R, the second R as 27.6393. Now the question is, which value of R do we take? Now it's not this R, the R is the whole of this distance, because it has here 20 already. And this 20 already, that's already 40. It means that now our R should be greater than the 40, which is 20 plus 20. So there, our R is going to be 72.360. That. Now from there, after getting R, what is R? Why are we getting R? The question is to get R, because you see this one, we have our PQ. But now, we can easily first get the Q from here. I think it's that R Q squared from here. So R Q squared is equaling to, even we have it here, R Q squared from here. From 2 is equaling to 2HB, which will be 2 into 100 into 9.8. If we take here our Q is going to be, here we just get a positive of it, so this is going to be 290. It's going to be so here my Q is going to be 44.27, and this Q is saying this Q is the same as our UX. So we have that now. What are we missing? We are missing our P. Where do we have a P? So from here, so we can easily use this to get our P. This one here. So we have R, we have everything here. I think we have it, so we can easily get our P. Do we have the X? We don't have the other X, so that one can't work for me. So now let me use this one from here. So that our P is going to be equal to U, okay, from here, the square root of square root of, now here, when I multiply here, I'm going to be getting b squared, r squared, the whole over 4q squared. It is going to give me, our g is going to be 9.8 squared times r squared, which is our r was 72.4606 squared divided by 4 divided by p squared 0.27 all squared. Root answer. So here I'm getting 8.0092 meters per second. Now my velocity, but remember, this is the same as our units here. So implying that, now my velocity, v, is going to be equal to the square root of pq plus q squared, which will be the square root of our q, our p, 8.0092 squared then plus 44.27 squared. And so our velocity is going to be getting 44.9887 meters per second. So that's how we had to handle that number there. So in simple terms, this is how we get the velocity of projection, which is our u. Sorry, it's our u, not in p. Our u. Our u, the velocity of projection, which we get as square this, but this one is p, that one is q.